Hello everyone and welcome back to the third tutorial in my series on the topic linear inequalities. The two remaining objectives that we have to attain in this particular topic are: number one, solve simple linear inequalities. We are going to solve the simultaneous linear inequalities in today's tutorial. The objective that we are left with will be represent linear inequalities graphically. Students, let's explore the first objective with an example. The question that we have here is: find the range of values of x which satisfies the following pair of inequalities. And the equation is x minus 4 is less than or equals to 3 and 3x is greater than minus 6. Now we have to come up with the values of x, the range of values of x, those satisfy these two inequalities. So students, in the first inequality, you can see that we have x minus 4 is less than or equals to 3. If we want to solve it, we have to apply the simple algebraic rules. What they are: take this minus 4 to the right or add plus 4 on both sides of the equations. So what are you going to get? You will get x is lesser than or equals to 3 plus 4, which implies x is less than or equals to 7. It gives us the values of x that are going to be true. If you substitute any value of x that will be lesser than or equals to 7, this equation will be a true equation. In the second part of this inequality, what we have is 3x is greater than minus 6. Again, doing simple algebra, we will divide both sides by 3. And if we divide both sides by 3, we will get x is greater than minus 2. Now students, if we combine both the inequalities together, what we have: x is greater than minus 2 and x is lesser than 7. So what is the range of x? X can have the values in between minus 2 and 7. The values of x are greater than minus 2 and values of x are less than or equals to 7. So the possible range of values of x are, starting from minus 1, if we talk about the integral values, 0, 1, 2, 3, 4, 5, 6 and 7. There can be any value of x that lies in between minus 2 and 7. The second part of the question, students, what we have here is we are given with the different equation. 2x plus 5 is less than 15 and 3x minus 2 is greater than 6. So let us first solve this first part of the equation. We will take 5 to the right hand side. 15 minus 5 will give you 10. Divide both sides by 2. You will get x is lesser than 5. To solve the second part of the equation, that is 3x minus 2, we will take minus 2 to the right. That gives 3x is greater than 8. And if we divide both sides by 3, we will get x is greater than 2.666. If we want to find the range of values of x, then that is x is greater than 8 over 3 and x is lesser than 5. Just remember, students, you have to consider these things as greater than, because we are talking about the values of x. So we can say x is greater than 8 by 3. If you like, you can read it other way around. 8 over 3 is lesser than x, or x is greater than 8 over 3 and x is less than 5. So this is the range of values of x that will satisfy these inequalities. Let us further explore the same concept, how we can solve the simultaneous linear equations if the questions are given like this. We have minus 4 is less than or equals to 2x and 2x is less than or equals to minus 2. Just remember, students, if you are given which 2x is greater than or equals to minus 4 and 2x is less than or equals to minus 2, divide it into two separate inequalities like this. Minus 4 is less than or equals to 2x and 2x is lesser than or equals to minus 2. Remember, 2x will be repeated in the first inequality and also in the second inequality. That is, the middle term should be written twice. Now if we solve it, we will get minus 4 over 2 is lesser than or equals to x. That will give minus 2 is lesser than or equals to x, or you can say it other way around, x is greater than minus 2. Now dividing both sides with 2, we will get x is less than or equals to minus 2 over 2, or x is lesser than or equals to minus 1. Now student, if you take both these inequalities simultaneously, what are you going to get? X is greater than or equals to minus 2 and x is lesser than or equals to minus 1. So we can have the values of x in between minus 2 and minus 1, means minus 1.95, minus 1.6, minus 1.5, minus 1.1, minus 1.01 and so on. If we represent them on the number line, let us first draw the number line. What we have the range of values of x starting from minus 2 and moving towards the left infinity. Then we have the 2 and moving towards the right infinity, that is the positive. Now the range of values of x is in between minus 2 and 1. Let us consider one more example to have the better understanding of this concept. Student, just think of 2x is lesser than or equals to x plus 6. X plus 6 is less than or equals to 3x plus 5. As I told you, what we are going to do, we will write the algebraic expression in the middle of the inequalities twice. So we can write 2x is lesser than or equals to x plus 6 and x plus 6 is less than 3x plus 5. Now let us first solve the first part of it. So we will get 2x minus x is less than or equals to 6 and x is less than 6. 2x minus x is x. By solving the right part of the inequality, we will get x minus 3x. It is having the positive sign here. If you bring it to the left, it becomes negative. Take 6 to the right, it becomes negative as well. X minus 3x will give you minus 2x is less than minus 1. Now students, there is a very important thing to note down here. As I told you in the previous tutorial, if you are dividing negative number on both sides of the inequality, remember to reverse this sign. Just consider this, you are dividing both sides by minus 2. So you have to reverse it as put this sign as greater than. Just remember this simple rule. When negative is multiplied or divided on both sides of inequality, sign must be inverted. That is, lesser than must become greater than. This lesser is converted into greater than. If it would have been the greater than sign, it should have been converted into the lesser than sign. Now the last step is we have to represent this information on the number line. So draw the number line starting from 0 and moving towards 6, and we have the range of values of x that is greater than 0.5 and lesser than 6. So we will get 0.5 in between 0 and 1, and 6 is lying somewhere here. So the range of values of x is starting from 0.5 till 6. This is the considerable region which will satisfy both the inequalities. Let us now dig deep into the topic by complicating the issue further. If we consider this problem, we have the length and the breadth of a rectangle are x and y centimeter respectively. If rectangle has an area of 24 centimeters square, state the possible pairs of integral values of x and y where x is greater than y. Students, we are given with the rectangle with its length as x and with its breadth as y. And rectangle has an area of 24 where x must be greater than y. So we have to come up with the values of all the values of x and y. in order to find the solution of it, we need to remember the area of the rectangle. What it is? Length times the breadth, means x into y. So let us first draw the rectangle having the length x and the breadth y. So here we have its length represented by x and its width or the breadth represented by y. Now students, one thing is for sure, the area that is lying inside the rectangle, it is equals to 24. So we have to come up with the pair of x and y. There are how many pairs of 24? All the factors of 24. So let us first write all the factors of 24. How we can write them? We have the possible pair of length and breadths that make 24. They are 1 into 24 will give you 24, 2 into 12 will give you 24, 3 into 8 will give you 24, 4 into 6 will give you 24. Similarly, repeat them. 6 into 4 will give you 24, 8 and 3, 12 and 2, 24 and 1. So these are all the pairs of the numbers that will give you the area equals to 24. Where the first part of it, this is representing the values of x. And this second part is representing the values of y, means breadth, and x means the length. Now we have to consider this important information that the length means the values of x. This is the first part of it. This whole column, it must be greater than the second part of it. Now if you consider the first pair, x is lesser than y, means length is 1 and the width is 24, which is not satisfying this inequality. The second part of it, 2 is the length and 12 is the width. Again, it is not satisfying this inequality. X is here smaller than y, not greater than it. The next part is 3 into 8. Again, it is not satisfying. If we dig deep into it, we will find that only this portion of these factors satisfy this linear inequality. Here, consider x, which is 6. Consider y, which is 4. Means x is greater than 4. 8 is x and y is 3. So 8 is greater than 3. So these are the all values of the length and breadth that satisfy this. And in order to find the possible pairs of integral values of x and y, these are the possible values of the pairs of x. And 6, 4, 8, 3, 12, 2 and 24, 1 are satisfying this linear inequality. And students, this brings us to the end of today's tutorial. I hope it has some value to your mathematical concept. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial. Till then, it's goodbye.